We breathe it every single second of every day. Oxygen. It's literally the element of life, right? But what if the very thing that keeps us alive could also be, under just the right circumstances, a really potent poison? It's this wild paradox at the heart of the very air we breathe that we're going to get into today. And get this isn't some new idea. This warning is almost 250 years old, and it comes from the most unlikely source, Joseph Priestley, the guy who discovered oxygen in the first place. Back in 1775, he had this hunch that breathing pure oxygen might cause us to, in his words, live out too fast. I mean, how incredibly ahead of his time was that? He sensed a strange paradox at the heart of his own incredible discovery.
So yeah, let's explore that paradox. Because it's true, we absolutely cannot live without it. But prolonged exposure to oxygen, especially at high pressures, can have some seriously toxic effects on our most critical systems. This is oxygen's dark side.
Priestley might have had the first inkling, but wow, it took science almost 2 centuries to really catch up. Our understanding of oxygen's hidden danger grew piece by piece. First up, in 1878, you had Bert, who was the first to connect high-pressure oxygen to seizures. Then, Lorraine Smith showed that, hey, even lower pressures could damage your lungs if you're exposed for long enough. And by 1945, John Bean confirmed the terrifying possibility of irreversible neurological damage. It was this slow, careful uncovering of a threat hidden in plain sight. So here's the crucial thing to understand. Oxygen toxicity isn't just one problem. It's actually 2 very distinct issues, and they're named after the people who found them. You've got the Bert effect. That's the fast, high-pressure problem that hits the central nervous system and can cause seizures. But then you have the Lorraine Smith effect, which is way more insidious. It's caused by lower pressures over a much longer time, and it goes after the lungs. So 2 totally different paths to the same toxic result. Okay, so we know what happens, but the next big question is how? How does oxygen, the very element of life, turn against our bodies on a cellular level? Well, the answer lies with a microscopic villain, and its story is pretty fascinating. Meet the free radical. Now, in simple terms, you can think of these as tiny, chaotic wrecking balls ping-ponging around inside our bodies. Normally, our cells have natural defenses to clean them up. But when you're exposed to way too much oxygen, your body gets flooded with these free radicals, and they just completely overwhelm those defenses, letting them attack all our essential cellular machinery. And this damage, it happens in a devastating chain reaction. It all starts with hyperoxia, which is just a fancy word for too much oxygen, which, as we just saw, creates a flood of free radicals. These radicals then go on the attack, disrupting the very structure of our cells. It's a process called oxidation, and it damages their protective membranes and crucial enzymes. This assault basically cripples the cell's ability to produce energy, and that leads to a system-wide failure that can result in cell injury, impaired function, and even cell death. So we've covered the how, but now let's get to the really practical question, when? What are the real-world conditions, the specific combination of pressure and time that actually push our bodies over that tipping point into toxicity? Let's get really specific here. If you were actually experiencing central nervous system oxygen toxicity, what would you feel? The thing is, the signs can be surprisingly subtle at first. Yeah, these early warnings are super varied, and they can be really deceptive. It might start as something visual, like your field of vision just narrows. Or it could be muscular, like a subtle twitching in your lips or face. It can even be cognitive, like a sudden, weird feeling of apprehension or just being clumsy. And while all these symptoms seem totally disconnected, they are all warning signs that the central nervous system is under attack and could be a prelude to a full-blown seizure. Now, I know this all sounds pretty alarming, but here's the good news. These limits are actually very well understood, especially in fields like deep-sea diving and medicine. For instance, it's pretty well established that a healthy adult can handle oxygen at 3 times the normal atmospheric pressure for about 3 hours before toxicity becomes a major risk. But, it's not always quite that simple. That 3-hour limit is really just a baseline. It turns out there are a surprising number of other things that can make a person more susceptible and can lower that safety threshold. And this is where it gets really, really complex, because that safety threshold isn't a fixed thing. All sorts of factors can make you more vulnerable.
For example, having higher levels of carbon dioxide in your blood, which can happen when you exercise, can actually increase blood flow to the brain and speed up the onset of toxicity. Even common drugs like aspirin or just having a fever can lower your body's tolerance. It's a powerful reminder that our bodies are just this incredibly complex system of interconnected variables.
So, given all these risks and all these variables, how in the world do we safely harness the power of high-pressure oxygen? Let's turn the corner and look at the solutions and strategies we've developed to tame this toxic element. So, how do we fight back? Well, we have a whole toolkit for managing this risk. It can start with things like antioxidants, think vitamin E, that help neutralize those damaging free radicals. A really clever technique is using what they call intermittent air breaks, which gives the body a moment to recover during a treatment. But honestly, the most important tool of all is simply the meticulous, careful control of pressure and time, those two core variables of oxygen exposure. And this is exactly why, if you've ever heard of something like hyperbaric oxygen therapy, you really shouldn't be alarmed. In modern medicine, these toxic effects are incredibly rare, and that's because physicians are using the very science we've just been talking about. They use air breaks, they control the dose with unbelievable precision, and they are constantly monitoring their patients. It's really a perfect example of a powerful force being harnessed safely through scientific understanding. And this brings us to one final fascinating thought. We've spent this whole time talking about oxygen toxicity as a danger, something to be avoided at all costs. But what if we could flip that idea completely on its head? The source material we looked at suggests we could actually exploit oxygen toxicity for therapeutic good, using it to kill pathogens that have no defense against those free radicals. A poison turned into a precision weapon. It's just a powerful reminder that in biology, the line between a cure and a poison is often just a matter of dose.